Hello and welcome back to the Eddystone, the 870. I've basically reassembled things. I have not finished off the cosmetics. I've not tried to do a label for Eddystone. I have primed the finger panel, but I've not put anything on it. I have got some water slide stuff I want to try at some point, and I've not got any further with doing the rear case. What I have done is made a new side panel in the garage. It's a bit, well, it fits, but I could have done better, I think, after a bit of time. The transformer has been mounted. For the time being I've left that. It's working. I can keep it out of the way. It's not the best looking thing. Quite a few of the wires that went to the original panel were that heat damaged. They were very brittle, and basically the insulation started to snap off when the wires got bent. So I have done a few changes. Not saying it's going to be staying like this. I have fitted a bit of tag board here which has got a thermistor, a resistor and another small thermistor, which are in series with the lamps and the heaters, and that little thermistor is in parallel with the two dial lamps. What I have done is got the IEC mains coming in. It goes to two 500mm anti-surge fuses to the switch, and then from the switch it goes to the 240V primary. The 110V secondary comes down to two places, one which is for the anode of the rectifier valve, and the other one is through here, which then goes off to the dial lamps and heaters. So the heaters are still series at 150 milliamps from the 110 secondary. So it still takes a while for the heaters to come on. The transformer, or the choke, this is the choke that was normally there. That's been roasted. So at the moment I don't have a choke in there. I might put something across these tags, some separates, that will then be on the mains input. What I think I'd like to do, I know I'm not going to have my fingers in here too often, is put some sort of finger guard over that, and if I can, over the fuse area. So those are future type cosmetics. You can see here, hopefully, the capacitors 1, 2, 3, 4, 5, 6. That's been restuffed. There's a new capacitor there, and the main smoothing cap has been restuffed. The rest of it are okay. Most of these are like 270 PF and a few silver markers, which, unless I can actually find a problem with them, they'll be staying as they are. I shall be tuning it up, or checking all the tune and making sure it's tracking the best I can, see if there's any issues with that, using this, which is one of my old test sets, an old IFR 1000A. Okay, I have the test set to 465 kilocycles or kilohertz. Attenuator output. I have been able to, because I've actually put the transformer in and it is now an isolated from the mains chassis. It's no longer what was called a universal type chassis for AC/DC. The chassis is now in fact grounded, so that means to say I can quite happily connect the earth side of the test set to the earth of the chassis. And I'm only using scope probes. I'm only talking of low frequencies. The scope probes are supposedly good up to 100 megs. but when I'm talking of HF frequencies, they should quite be capable of doing it. The first thing is to check the IF. So I've got the output transformer going to the scope for the speaker, so it's going to be basically peak and adjust on the IF stages. I'm not really expecting it to be out at IF level. It's not these I expect to be out, and you get quite a nice little visual and audio confirmation when everything's okay. And these look as though they've been okay to start off with. Yeah, everything's okay, so they are good at 465 kcs. On this, from the signal generator, it's connected to, or the ground is onto chassis, and the RF output is to the stator on the back variable capacitor. Okay, the manual says start off at band 1, which is the highest band. Set the SIGGEN and the pointer to 6.5 megs. Inject a signal, and then check. This is initially just doing the lower end of the bands. Check that the oscillator is peaked. Let's see. And while I'm here, I might as well just check that one. Okay, so that's set at 6.5 megs. It says move to band 2. Take it to 2 megs. Take my generator to 2 megs. Looks to be a bit off. So let's take it to band 2. Let's set the oscillator. To be there. RF amp was out a bit there. Band 3, it wants me to do 600 kcs, so let's move the dial again. 600 kcs, drop this down to 600. 600 kcs, band 3 is this one. I'm getting some pickup. Peak. And peak on that one. And the last one is 160 kcs, 150, 160 kcs. On band 4, nothing. I've skipped ahead of the fault a little bit. I've tuned up bands 1 to 3, which are the HF bands done at the bottom and top end. I might have to go back and check them again, but what I'm going to do now, if I just put my scope onto the cathode end of the oscillator valve, that there is the medium wave oscillator, but switching to the long wave, the oscillator dies. So there is nothing there. There is something on the other bands, but the scope on this is very limited. So you can see the bottom HF, and it should be fine seeing the long wave oscillator, but there's nothing there. Now the only real things that's changing, if it's running on the higher frequencies, it's not going to be the valve itself, and basically the band switch is selecting one of 4 coils, and each coil has associated with it 2 extra silver mic capacitors and the trimmer. Now it's possible something has gone short or the coil is open circuit, so I shall now be able to power it down and do some volt checking, test some continuity and make sure the caps aren't short and stuff like that, which I might mean to say I have to strip it down a bit, but we'll see what it brings. I hope this is clear enough, and I hope I can hold it still enough. This is the oscillator valve. The cathode is raised slightly from ground potential. If I look at each coil, it's a tap coil. The tops on each one have, well, this is band 1, which is highest frequency, is basically just the coil and the trimming cap, with the cap leading out to give the feedback. L6 doesn't have a padder cap, it's just the coil and the trimmer again. The medium wave and the long wave both have padder caps across the trimmer. So looking at L8 here, cold end of the coil, few turns off to the cathode, top end of the coil has got the parallel C and parallel C there to trim it. The main cap is across here being fed back through these caps. Now on all these, if I go across the trimmers, I am seeing the resistance of the coil. Apart from this, if I go onto the long wave section, there is no continuity if I meter across any of these 2 caps. So in other words, it means to say L8 somewhere is open circuit. So that's something I'm going to have to look for. This coil is now going to have to come out. This is L8 coil down there. The trimmer cap, the padder cap is underneath it here. This connection goes off to what is C24. This is, by the looks of it, a common ground connection, and this pin here, this connection here, is the one that goes off to each of the vanes on the switch to connect each coil in turn to the cathode. So there's going to have to be 3 wires unsoldered, that one, and that one, and hopefully I should then be able to withdraw the coil and the components to see what the fault is.